Ćao Nikola.
Ćao.
Taman smo te pomenuli. I odmah si ušao.
Prizvali ste me.
Bukvalno. Si dobar?
Super.
Jel ti sva ova pitanja odgovaraju ili...
Ma da. Pa i dosta toga je i u videu pokriveno, tako da ići ćemo spontano na bazi toga šta nije pokriveno.
Važi. Šta? Imamo neki... Čekaj, šta je bilo stanje?
Kako se vi nalazite, kako ide? Jutros.
Ja nas slušam na live streamu i slušam nas ovde. I onda mi live stream kasni 1 minut. I izgleda mi kao da ponavljamo razgovor. Ali dobro, znači pričat ćemo na engleskom, ja ću ti naravno najavit ću naš razgovor i postavit ću ti prvo pitanje, tu ćemo malo da pričamo, jedno 5 minuta, 5 do 10 minuta, ništa više, pa ćemo pustimo klip i onda na kraju ćemo da završimo sa nekom diskusijom, bilo bi super da imamo ljude koji postavljaju pitanja, vidjet ćemo koliko će, imamo mi dovoljno pitanja za nas dvojicu.
Baš, pa imamo sigurno.
Ništa, ajde ako hoćeš uzmi kafu za 3 minuta da krenemo polako pa...
Imam sve, tu sam.
Važi. Ništa, onda ću ja da se mutiram naravno 3 minuta.
I ja ću, pa...
So, welcome everyone to the session after lunch on the Balkans Go Circular virtual conference that is organized by team guiding circular economy beacons in the Balkans and also supported by AIT Climate Kick. These 2 days we were talking, and still we are talking, and we will be talking about the innovation, the innovative side of circular economy, the Balkan perspective of it, and how can we accelerate the change toward this good economy. We talked about theories, we talked about practice, we talked about cities, we talked about businesses, and also about policy making. These interconnected topics are something that is definitely necessary in order to understand the real character of circular economy. And the real character of it is systems thinking and systemic effects. 3 words that we like to share constantly and that we would like to ring outside the conference are enjoy whatever material we're presenting or whatever material you are able to find. Engage between yourself and together with us in order to get the most out of this conference, and at the end excel in everything that you say or do, especially as a follow-up activity. And that's maybe the focus that we would like to lean on in this also session, is how to excel in when the talk becomes practice, when teaching and learning becomes something that is implementable and workable around circular economy, when something intangible really starts to become tangible. It is a great pleasure that today I can welcome Nikola Stanojević, that is our innovation circular guru, I would like to say, and the man that is creating new innovative materials, completely biodegradable and completely circular. That's one of the first, not the first, but one of the first innovation that are most probably scalable to, of course, outside of Serbia, outside of region, and we would really like to see how it flies all around the world in fight against single-use plastics and other petrochemical products that are currently polluting our lands and our seas. Nikola, thank you very much for joining us. We will dedicate next 40-ish minutes, maybe to an hour in talk, and also presenting your product as a spin-off, or not a spin-off actually, but as a continuation in story. After all your strivings, after all your goals and successes, but also as part of the Academy for Circular Economy that was here to present and shed a little bit more light towards something that you are engraving your deeds into. So Nikola, why don't you just start with maybe presenting shortly who you are. How did you come to the idea of creating Biosporin, which is a new biodegradable material, and how do you see circular economy as itself? Let's start with you. Who are you?
Okay. First off, thank you for the wonderful introduction, and thank you for your praise. So I'm Nikola, and I'm from the company White Lemur, and we have a project within the company called Project SOMA, where we are trying to create and innovate new materials, mostly biotic types, to replace different types of plastic materials and different types of wasteful uncircular materials. And the first innovation that we have brought to market is called Biosporin, and that's a biodegradable substitute for styrofoam, as Milan pointed out. So the path to getting there was not a straight line at all, as usually innovation isn't. So when we began our project, we began it as something completely different. We were actually, and we still are, producing pharmaceutically active mushrooms for use in the supplement industry. And during that time, we basically figured out that we can use a part of the process and we can use a part of the material that's produced to create certain materials that have the technical characteristics of styrofoam. And at that point, we also came in contact with the Academy of Circular Economy and with Milan. And through our period there, we learned a great deal about what circular economy is, what circular products are, because you don't really go set out to create a circular product or create a circular process from scratch, because circularity is about adapting the existing things and existing products, existing processes into a more sustainable framework. And the best way to go about it is to start doing something and then start thinking from scratch how you can implement it more circularly and more circularly, because it's a process. In every iteration of development, you will learn something more about how you can innovate that direction. So we have a video prepared, I believe, that will mention all of this and mention a lot about our product. So I would like to repeat myself.
True. Again. Instead, well, I mean, definitely we will know about how the product has come to be and what was all the process. But if you would like to describe Biosporin, tell us a little bit more about its characteristics, about where can you use it, what is so special about it, and who would actually like to buy it? Who is this intended for?
Yeah. Well, in short, when we created it, we saw that it has potential to mimic styrofoam, and it has the technical characteristics of being light, being relatively elastic, and being shock absorbent. Mm-hmm. And those were some technical characteristics that were pointed out about it. So they basically defined what kind of usage it can have. Mm-hmm. So when we started developing in that direction, we also saw that it has some other sets of capabilities which are different from styrofoam, but are not necessarily related to the fact that it's completely biodegradable or circularly produced, but it's also fire resistant. And it has a flammability class of A0, which means it's inflammable, basically. Wow. It can sustain up to 1,000 degrees temperature. So among its characteristics, starting from production, is that its production process in total uses 98% less energy than the production of an equivalent amount of styrofoam. Mm-hmm. It's produced entirely from agricultural waste, so from the same waste that's being burnt on our fields every fall, which is an abundant resource in Serbia, as well as another source of pollution. Mm-hmm. And it's produced in a biological process. So the material is basically a biotic material, and it's created out of mushrooms. So we use a specific strain of mushrooms in a liquid form to turn waste into biosporin. So the process itself is carbon negative. So as the mushroom grows, it captures additional CO2 from the atmosphere. Mm-hmm. And when we have a final product, when we have grown a final product in the form that we want it, it can be used. And when it is used, it has a few more cascades of return, where a mechanically damaged product can be returned back into the same production process, reused again as feeding stock for a next generation of mushrooms. But it can also be degraded and thrown away, so basically broken up and thrown outside, because in contact with soil and with the earth and bacteria, it migrates into organic fertilizer. And the Faculty of Agriculture has also done a study on it to quantify how much, so it doesn't actually leave any solid detritus. And it basically completely degrades into organic salts, so it doesn't take up space on dumps either.
Mm-hmm. And who would like to? I mean, who would have to use it? Who would like to use this product?
Well, we hope everyone would like, of course. But the thing is that our product is aimed. Why we aimed it at styrofoam, at industrial styrofoam first. As a styrofoam replacement, it can have many potential uses. Mm-hmm. However, the one that we are aiming to replace in the market that we are aiming to enter is single-use packaging market. Okay. Now, this is for multiple reasons. First, because also as part of the analysis that we did at the Academy of Circular Economy, we realized that single-use plastic packaging and single-use styrofoam packaging is one of the main sources of pollution, because it's not styrofoam is one of the rare types of plastic that cannot be recycled at all. So it's either burnt or it's thrown into landfills where it degrades into microplastics.
So you basically grow the material and grow it into a shape that is further on necessary to be, well, definitely transported.
So difference from, instead of styrofoam is inject molded and expanded into a mold that you want, and Biosporin is grown into a mold. So it's similar in that regard. In difference from other types of materials that you can make shapes from, we don't have any waste because we grow it directly in the form that we want it to be. So there's no wasteful production. And just to finish off that single-use, why we are targeting single-use plastic packaging and who will have to buy it, because single-use plastic packaging is slowly being regulated by the law. And as per the European Union and our country as well, from 2021, many types of single-use plastic packaging will become unusable. They will be forbidden by law or they will be heavily taxed. So our idea is to provide an innovation that has all the technical characteristics of styrofoam that was used up until now, but is circular, sustainable, and biodegradable, and doesn't require other businesses to adapt their logistics in any way. Because changing your packaging from a styrofoam packaging to another type of packaging for shock absorbency is possible. There's bubble wrap, there's all kinds of different things that you can just transfer into. However, they are a different type of packaging, and they require you to adapt your box size, to adapt your logistics, to adapt how you produce, basically, and how you transport. And our idea is to provide businesses with the service of designing, prototyping, and mass producing single-use packaging without them actually having to change anything in their logistics or the specifics of their product.
Great. Yeah, I mean, I would buy it, and I think we will have. Well, definitely, we're going to foster some collaboration on this. It is. Yeah, well, it is a great product, and I would love to have even more people on Zoom, not only the 2 channels that we're streaming, or actually 3 channels that we're streaming on via Facebook, via YouTube, and via our Collective Vibe, or actually Circular Economy Beacons conference platform. This is a warm welcome to everyone that would like to also join the Zoom meeting, in order to have even more interaction or to have your questions posted, because now we are going to switch in next 20-ish minutes, a little bit over 20-ish minutes, to see what actually Biosporin is about, where Nikola will explain us bits and pieces about this. And then we would like to welcome all of the participants back into the Zoom meeting and have a little discussion definitely about all the details that you are interested about. So, Nikola, thank you for the short introduction, and I would like to ask support staff from Collective Vibe just to push a video and to have this pre-recording set. If you're ready. If you're not ready yet, we can talk maybe a couple more minutes more.
You can go ahead.
Okay, Collective Vibe is starting.
The video is ready. Enjoy.
Perfect. Thank you, and see you in 15, 20, maybe a little bit more minutes. And please share the sound. Yes.
Imagine a world without plastic waste, without microplastics in our drinking water, without microplastics in our bodies. Imagine a world where the air you breathe isn't toxic and polluted, but of the quality you deserve. Imagine a world where you get your favorite phone in mushroom packaging. That world is possible now, because we are making the mushrooms that will help the world. The idea to create Biosporin came from a variety of sources. So our company has been very diverse from the start, and part of the company worked on designing partially sustainable or green material, promotional materials for promotions on airports or similar things. And while during that we noticed that there are not many suitable material substitutes for plastic materials around. Simply, if you want to go green with promotional material, you have very little choice. And some big installations that are made for airports and similar stuff require a lot of styrofoam. And they're used only for one season, they're used only for holidays or something like that, and then they're thrown away. Another source came about at the same time that we were producing pharmaceutical mushroom, which is used to produce supplements and pharmaceuticals. And while growing it, we noticed that the mushroom material has a lot of special qualities, and one of them is that it can, in certain conditions, be used as a material that has almost the same characteristics as styrofoam. So we noticed that, but it didn't really click until we were also aware of the other issue. And then the idea came about to use the mushroom material and create a sustainable and biodegradable substitute for styrofoam. That was a little over 3 years ago. So development has been for about 3 years. It took us about 1.5 years to create the first prototype of the material, which has all the technical characteristics of styrofoam or of expanded polystyrene, and then another 1.5 years to make it into a suitable, commercially viable product. So the big 3 problems, let's say, that we are solving with our material is, number one is plastic pollution. So microplastics and generally removal of plastics, environmental issues, let's say it that way. The business perspective, from which we know that legal action has been taken to reduce single-use plastics. And a lot of countries are banning the use of single-use plastics now, which will create opportunity for business and opening on the market, where businesses will have to transition into a sustainable and green packaging solution. So our idea is to offer a sustainable packaging solution that has all the technical characteristics of the material that was used before, so as to minimize disruption to already existing businesses and to already existing logistics and ease the transition. So we plan to become the number one for the green transition of packaging. And third problem, which surfaced in the meanwhile, is that in some countries, especially third world and developing countries, a lot of agricultural waste is burnt. In developed countries, there are certain circular systems that capture the waste streams from agriculture and use them to produce methane, to produce feedstock, to produce different kinds of usable products. However, in Serbia, we don't really have any mechanisms like that yet. And agricultural waste is burned en masse. And a few years ago we had a situation where the air was stagnant, the atmosphere wasn't circulating, and all of the smoke was captured around the city, which produced enormous amounts of terrible pollution. So we turned the production of our material towards waste streams, towards utilizing such waste streams. And we had the idea to try and use cellulose and lignin-rich agricultural waste to produce our material. One thing about our material is that it's not produced in a classical sense. Our material is grown. So the agricultural waste is actually used as the food stock for the mushrooms, which then grow through the substrate and grow into the shape that we want them to of the mold. As I said, we have several circular stages at our material. So the first cycle would be the fact that our material is produced from agricultural waste, and when its life cycle is completed. First to say that our material is completely biodegradable. However, it won't biodegrade in dry, normal room conditions. The only conditions in which it starts biodegrading is when it's in contact with soil and has a lot of moisture for an extended period of time. So when it's thrown outside into the dirt, into a field, into a forest. Then bacteria from the ground start dissolving it. And what happens then, and this was a study by the agricultural faculty in Belgrade, it was proven that Biosporin within 4 to 6 months biodegrades completely, does not leave any solid wastes, and it basically melts into organic salts. And those organic salts then fertilize the ground. So Biosporin actually degrades into organic fertilizer, and it can be used as an addition to fertilization for fields. So it again fertilizes the fields from which crop grow, which we then use for agricultural waste and cycle it down. Another level is that if the material is physically damaged, but not chemically, so if it doesn't start biodegrading, it can just be put back into the production process because the mushroom is cannibalistic. It will re-eat and reintegrate parts from its waste. Another line can be that when products from Biosporin are physically degraded, but they haven't been chemically damaged, they can be shredded and used as soft, instead of soft filling, instead of the pellets from styrofoam, for softer packaging. So that's another cycle which we have. And we are currently working, as I mentioned before, we also have a mushroom growing aspect to the business, and we are growing pharmaceutically active mushrooms. Now, how these two are related is that actually the entire production process is the same production process up to a final point at which they diversify into whether we will use it for production of pharmaceutically active mushrooms or we will use it for biomaterial. But then the waste from the mushrooms which are used for the pharmaceutical extract can also be returned back into the material. So we are constantly innovating in these fields and trying to make as many circular steps as we can in order to have an almost completed circular process. And we require very little resources, actually. And that's also one of the problems that in bookkeeping we have with entry materials, because we can produce pharmaceutical products, tea, biomaterials of different kinds, but our only input is agricultural waste. And we actually don't use any other resources. We use some equipment during the growing, but most of it is reusable and reused. So there is very little waste in the sense of plastic bags which we use to sterilize the substrate. They are recycled. So we have quite a lot of entry points, with the only negative sides. Now, the only, of course, everything has its positives and its negatives. One of the negative sides of the production of this material is its requirement of space and time. So we use very little energy. The production process uses 98% less energy than production of styrofoam per same volume. It generates no wastewater, it generates no solid wastes, it's carbon negative, which I will explain additionally. However, the space that you would require to compare to styrofoam, you have one extruder machine for styrofoam, and that machine can produce an endless amount of objects from styrofoam by simply extruding them into a form and popping them out. And that process lasts a day, let's say, for bigger styrofoam objects, and a few hours for smaller ones for single object production. In our case, our material has to be solidified or grown in a space that it occupies. So our capacity to produce is limited by the space we can use for growing the material. So one cubic meter of material needs 1 cubic meter for up to a week to be completely produced. Now, this, of course, is a weakness in a scaling sense. However, we think that one advantage next to the agricultural waste being abundant and free, basically, in Serbia, one other advantage is that space is also less costly here in Serbia than it would be in other European countries. We have a lot of unused industrial space in our country, and we believe that by utilizing part of that space, we can easily scale up production to a much bigger scale, because the technology we require is easily scalable. It's very linear in its scaling, so more space literally equals more biosporin produced. So, as I said, biosporin has a lot of different physical qualities and can be made to have a lot of different physical qualities. Its major attributes are, number one, that it's completely biodegradable and ecological to produce. And number two, when it's compared to styrofoam, it's actually non-flammable. The material is a 0 flammability class, so that means it doesn't catch fire, ever. It starts combusting, so it turns into ash at around 1,000 degrees. So it's highly inflammable, and that is a very strong bonus compared to styrofoam, leaving aside everything else. So our first target, as I said, is packaging industry, because that single-use packaging is the major source of pollution, both air pollution, land pollution, water pollution, microplastics. However, the material can also be, we have a lot of inquiries from the building industry. And a lot of people are interested in using it as a sustainable isolation, because it's very thermal isolational. It's actually has the same thermal capacity as styrofoam, so it can isolate in the same sense. We are getting a lot of inquiries from people who are building ecological homes or ecological hotels or bio cottages and similar things, who want to use our material as isolation. Now, that use is very also important, because the building industry is the second consumer of styrofoam after the packaging industry. However, the bonus of our material, so being biodegradable, also prevents it from being used as a long-term solution, because if it would happen that the isolation layer gets wet, it would start biodegrading in a while. So in that sense, it couldn't be used as natural. However, we have a project with the technological and metallurgical faculty and with a private laboratory where we are developing a coating for our material, which should impregnate it and make it completely hydrophobic. So by making the material completely hydrophobic, we are actually also stopping it from biodegrading. Now, the rationale behind this is that this coating is actually produced from recycled bioplastics. So it's also a circular moment. However, while the coating is intact, the material won't biodegrade. However, when the coating is physically broken, so if I make a hole or a puncture in it or crack it in any sense, it will start biodegrading. So this would allow us a much wider range of usage, both in wet conditions, as well as using it as a isolation for houses or similar. Also, one advantage when compared to other building materials and potential usage as is that it's relatively elastic. So our material has a bigger elasticity than styrofoam does. For everything else, it can also be used as acoustical isolation. So there is a company in Italy that are using a similar material, engineered in a way that absorbs sound waves, and it has a very good quality in absorbing them as well. And some startups from the US and from Netherlands are producing furniture from this material. Now, when compared to the competition or to others in the field of producing biotic materials based on mushrooms, except for our technical differences, because we all use different technology, is that our goal, our area, is to try and produce cheap single-use packaging. So we believe that if it's something that's biodegradable, then it should be used as biodegradable. It should be used to produce something that's single-use and disposable. There isn't much logic in making something that should last forever from a material that is biodegradable. It's the same level of logic that we use something that's eternal to make something that we use once and throw away. So we are trying to capitalize on the natural biological abilities that the material has. Well, after about 3 years of development, as I said, early development was about a year and a half to get to the prototype. Then with the help of the Innovational Fund, we got to a commercial product now. So right now we're entering our commercial phase. And we have a few commercial projects running where we are making packaging for components for sustainable toilets, which are produced in Serbia and exported to abroad. And we are also working on prototypes for sustainable packaging for perfumes and for bottles, for different kinds of breakable material. So those are all commercial projects that we are starting right now, and we have a few more, as I said, pilots experimenting with different applications actively on the field to see if we can also produce them in a commercial sense. So we are in the commercial phase now, but we are still in a half manual phase with production of our material, because the equipment to produce our material doesn't exist and it hasn't been designed yet. So we actually have started designing the machines that are necessary to produce our material in a half automatic or automated sense. And we have designed the first of those machines, which we are using now. So we are using a partially automated system to produce them, but it still requires a lot of manual labor. So to properly scale up, we plan to finish designing the production process and the production machines, and then to scale up with both space and production power to be able to accommodate the market, because there is a lot of demand and there is a lot of interest, and that's definitely undeniable. The only question is how quick we will be to rise up to produce to that extent that's needed. Our main goal is to actually develop the technology for the production and package it in a neat pipeline that can then be licensed to other companies, because we have applied for patents for the production machines. So we plan to hold the intellectual properties of the production process, which we can then license out to other companies, help them develop and set them up in the market, because that's a more scalable way to do it than us having to do all the production. And we believe that this can have a lot more impact, in the sense that if you allow other startups who want to use the technology to use it for royalties, it's easier for them to start and to get into the business than it would be to have to immediately get up with the technology and money from the start. And this kind of approach will allow us the widest impact. And our end goal is to have the widest impact and to reduce plastic pollution as much as possible, and ambitiously to replace all the styrofoam on the market with our material. So there is a lot of interest both nationally and abroad for our material, and maybe our first real inclination came when we won on an international European level competition for green tech startups in clean energy area, and we won the Popular Award by voting, and that gave us a kind of sign that we are on the right direction, because votes came from all over Europe, not only from Serbia, and that made us believe that we are on the right track, both nationally and internationally. We have been contacted by the biomaterial biomaterial library in New York, who want to put our material in their library as a sample and as a existing innovative material. We have been contacted also by investment funds and accelerators from abroad, who are all interested in our material. And we have been contacted by a few businesses, and as I said originally, even the idea came from a few big businesses stating that they need something like this, that there is a need for a material like this on the market. Now the thing is that we believe that Serbia has potential, and we believe that our country can serve as a powerhouse for circular economy and for sustainability, maybe especially because we need it the most. Because in other countries, there's a lot of sustainable technology already, but there is a lot of greenwashing as well. And it's very difficult to differentiate between the two. Here in Serbia, we have a kind of a clean slate. There isn't much technology in the sustainable and circular area, so there is much room to grow. We have unused waste streams, which are very cheap and easy to use here, because our legal structures also allow us to use it without much issue, which would be a problem in the European Union because the usage of different waste streams is highly regulated. So it's easier to move here in an experimental sense. And we also, as I said, the space is here more affordable, resources are more affordable. And one of the things is that for businesses who will want to export to the European Union or to other bigger countries like the US and similar, we'll have to find a sustainable alternative. So our plan is to first offer Serbian businesses first pick of our material so they can package and export in it, and basically lift us as well as on a national level companies from Serbia and give them a kind of a sustainable badge. We do plan to scale up our technology internationally, but it would be impractical to export the material as such. So local production is necessary. And when we start licensing the technology, we plan to basically change the main operations of our company into opening and helping new companies develop and licensing their technology in different countries, in places where there is a big need for packaging, like industrial zones, and that also potentially have access to agricultural zones for the waste streams. As we say, circularity and eco is our main thing with this material. And through collaboration with different institutes, with the Academy of Circular Economy and with the Smart Impact Fund, we developed sets of tools by which we can measure the impact of our material and by which we can calculate how much actually we are reducing pollution. So 1 ton of Biosporin that's produced and marketed successfully, so that replaces 1 ton of styrofoam on the market, reduces CO2 emissions by 8.9 tons, reduces methane pollution by 3 tons, reduces solid waste by 300 kilograms, and reduces ashes by 150 kilograms. And I'm not mentioning all the additional trace toxic chemicals that are released through plastic. So this is a summation of the different ways that Biosporin reduces. So starting from utilizing waste streams, which are then not burned but used for production of our material. By the material itself, while it's growing, it's carbon negative. It actually absorbs carbon from the atmosphere. So 1 ton of Biosporin absorbs 0.2 tons of CO2 from the atmosphere. We are by replacing plastic, we are preventing plastic being produced. So the emissions that happen during plastic production are reduced. We are reducing the emissions that are generated by burning the styrofoam. We are reducing the plastic waste and the microplastics that are created by having the styrofoam in dumps. And we are also reducing ash from the burning of both the agricultural waste and the styrofoam. Well, actually, when we began working on our material, we didn't even know what circular economy is, to be honest. So we actually started developing our material and then saw what it can be and what it can do. And one by one, the ideas came. And then we went to the Academy of Circular Economy. And through it, we actually realized what the terminologies are, what cradle-to-cradle design means, what circular design means, what eco-design means. And then we were able to frame what our product actually is and what it does. And through product life cycle analysis and through material flow analysis, we were actually able to quantify how much and what it reduces and where we could position it in the market so it has the biggest impact. So we realized at that point that it was circular and started pushing in that direction. Well, everything is possible with enough work, so they are possible. The fact is that they are difficult because there isn't much knowledge about circular economy at all, or ecology in general in our country. There isn't much awareness and there isn't much resources or funds. But as I said, that fact actually makes it maybe even more, yes, it's more difficult, but it's also more fertile. There is more space to work. There is more opportunity and there is more impact that we can make here. Because our impact here, where the pollution is greatest, is greatest. It would have been impossible to start without the help of some institutions, definitely. So the Fund for Innovations, which basically allowed us resources for innovative development, which wouldn't be possible without that help. And the Academy of Circular Economy for the guidance that we were provided into developing an actually circular product. Smart Impact Fund, which deals with social businesses and impact businesses in general. So there are a few ways that you can actually develop a circular startup in Serbia, and it's not impossible. The resources are there, the tools are there. It just requires a lot more work and a lot more dedication and devotion to it than would be developing any other business, I think. And also Serbia isn't really, we don't have an investment culture. We don't have an investor culture and we don't have, especially not in innovations. So getting early investments is difficult in Serbia. However, my advice to anyone starting a business, especially in circular economy and especially innovative businesses, would be not to aim for early investment at all. So try to develop your idea on your own, bootstrap as much as you can, and seek grant funding money from different funds, from different sources. Adapt your idea to what it needs to be for the grant, and then develop it through that. And then think about investments later on, when you actually have a product, when you actually have an investment. Because it's going to take much more work to get those investments in Serbia, as early investments, than it will to actually make the product itself.
All right, we're back. That was a lot of writing down from my side. How was the process? How was the development, etc., etc. Nikola, one very simple question: why? What motivates you to create this kind of product, not something that is easier or that is maybe easier to put on the market, or maybe more expensive, or with faster return on investments, with etc., etc. Why this?
Well, as Kennedy said, we do it because it's hard, not because it's easy. Well, because this is the future. I mean, the future has to be circular and it has to be sustainable, because not only from environmental aspects, we can always talk about environmental aspects, but if they cost more to implement than the current system, they're never going to fly. But the true sustainability in an economic sense is good for the economic system itself. And eco-capitalism is as I see it, the only solution to the current over-consumerism problem that we have, that's causing all the problems across the industry, across environment, across everything. So we kind of, by early work and investing loads of work now to push through, we plan to be early on in the field when everyone else starts going into it, because there is no other way. And big companies are also thinking about circular models and implementing circular models for themselves and in their core, as their core values. So it's unavoidable. The next 10 to 15 years, unless, you know, we get a crisis of 10, 15 years, everything should move in that direction.
There is always some unpredictable crisis waiting around the corner, I would say.
Absolutely. Right? Also, every crisis is an opportunity. I mean, the fact that the economy is paused now in most countries, that it started to collapse, that it's, you know, that this is all opportunity to restart the economy in a green way. And the European Union has actually adopted a plan for a green restart of the economy. Now, how green it is, that's debatable, but it's a step. It's a step.
Yeah, you mentioned European Union, and basically this whole project, Circular Economy Beacons, is supported, and also Academy for Circular Economy was supported by AIT Climate Kick, and they're providing a lot of incentives and a lot of direction towards systemic climate-oriented innovation. So other than this, how hard it was? You have mentioned some of the funds, but how hard it was to get the seed fund, or to get the first funds that help you in finalizing your product? And where did you search for help? You have also mentioned some of this was in Serbia, some of that was abroad, but let's try to dive a little bit deeper in this one.
Well, the early, so the very seed funds were private funds from us founders. So we all come from other businesses. I had a previous startup in London for about 4 years before committing to this project. So we did have a kind of a starting point in that regard, and without that, it would have been almost impossible, because if you have to do your normal job and you have to survive, and bringing an innovative startup online at the same time is very difficult.
Innovative, let's call it innovative way of living.
Yeah, it's an innovative way of living. Yeah, exactly. So of us founders, we all had previous positions or companies or something that we could, divert from and invest resources into this project before we came to seek outside funding, because we didn't. The point that we got grant funding, as I mentioned, from the Fund of Innovation, is at the point that we came to prototype. So we made a first prototype, and to make that prototype, we needed about a year and a half. So at that point, it's family, it's friends, it's the support network around you, and it's your own personal capital that you have to put into it to make it fly. Because no one is gonna fund an idea, put it simply. Ideas, people like to think that ideas are everything because everyone has them. But that's exactly the thing, everyone has ideas, and you can literally Google sustainable business ideas online, and you will find ideas. It's not about ideas, it's about the implementation. It's about being there at the right time with the right resources and the right connections. Because, someone else might be more capable to bring your idea to the market than you are.
Yeah. And in that whole pathway, what would you say that was a major barrier for you? What was that something that you wanted to, break everything around because it doesn't work, or you cannot, you cannot succeed? What was the biggest barrier?
Well, it depends. I would say there are two types of barriers. There's the internal barriers, which come from your own product, the development of your own product. So getting it to do exactly what you want to do. And that's roads filled with frustration always. And as we say, that the moment that it stops being frustrating is when you should start worrying, because you're not developing it anymore.
Sure.
So you have to always push all the weaknesses of your product and your production. From that respect, I would say it would be to actually think around the entire logistics and process for the production of this material, because it's a new thing, it's an innovative thing. So there's no other material that's produced in a similar way. You have biotic materials, which would be wood, straw, grass, or palm leaf, and all of that that's used. Cotton is a biotic material, and they're harvested naturally and on plantations. We produce it in a slightly different way from a new organism that hasn't been used to produce materials until now. and it isn't even yet brought to the genetic level that we want it to be ideal for the production of the material. So it's all kind of playing with a mostly wild that's notoriously difficult to control in a genetic sense, and getting it to make exactly what you imagined. So that's a whole pack of challenges on their own. And on the actually didn't meet much challenge in the regards of getting our product out or becoming visible or everything, but that also might be due to the collective experience that we have as a team. So we all have experience across different industries, some in big industries, some as founders and directors of their own companies, some in startups. So by combining our knowledge and expertise, we were relatively able to shape a product, and with the help of outside forces like the Academy of Circular Economy and the Smart Impact Fund, who also helped us to devise a set of tools to track our impact. And with the help of so many brains, it's not impossible. One that we are facing and that we will be facing, and that but that's simply a consequence of being innovative, is the fact that our material doesn't exist anywhere as a class. So when we want to get it tested, we have to find someone who's willing to devise tests that are going to be specific for our material, because you can't apply any other tests existing. And we've had the luck to meet a team that works on the Faculty of Metallurgy, Faculty of Technology and Metallurgy in Belgrade, who are working on our material at the moment. So from that perspective, it's also the legal binds around it, because our material, for instance, legally cannot be used to package food as a primary packaging. I think I mentioned that in the video as well, because our law simply doesn't see this material as existing at all. So it's many stakeholders have to come together to bring such an innovation to market. But that's our next big wall that we have to climb over, because first you have to make a product and then you have to push it through. You can't start, pushing something that you don't know if it's going to be a good innovation or not.
Yeah, well, you've mentioned a couple of things that I can, we can talk, I guess, for 2 hours at least, talking about systemic approach and multi-stakeholder, perspective, and also multi-stakeholder approach. As you said, I mean, coming to the idea is actually easy. Coming to the innovation is hard, but actually implementing it and putting this embedded in this whole socioeconomic system is the bingo.
Yeah, that's the hardest thing, because then you have to move many more systems than your own. And there are so many hurdles: economic, sociological, mental, emotional. People don't operate always on pure logic, so or ever.
Yeah, so we're not following this. It doesn't matter. I just wanted to throw in some theory. We're not going to talk about this. So we've mentioned Academy a couple of times, but what was actually the most useful for you there? Was it the knowledge, or was it people or network? Or if we are talking about knowledge, what directly was something that you were using? You've mentioned LCA and you've mentioned MFA, but other than this, or actually in what sense did you use these two things? And also what can you compare the influence level of network and people and knowledge? What was there good for you?
Well, from the top off, first thing, yes, knowledge, definitely, because through that we got the basic set of tools that we use to design our product as it is today. So the basic set, the basic glossary, the basic words: what is circular, what is systemic thinking, how you have to think to make a circular product. And that's a whole topic in itself, as you rightly pointed out. But circular product isn't necessarily a recyclable product. Many industries have recycling, but that recycling is same pollution or even worse than throwing it away. So recycling, when you say circular, people always just think about that, but it's not. It's reducing at every level of the system. So you don't have to have a truck that uses biodiesel instead of fuel and call it circular. The most circular thing is not to have the truck at all, to just remove the problem. So it's the framework of thinking, is the set of tools. And yes, as you said, the MFA and LCA are things that we now use almost daily, always. When we think about our product and when we think about the environmental impact, it's somehow ingrained into our way of thinking. You always think downstream and upstream, you know, catch all the branches of the product, where it's going to go, where it came from, where your resources came from, what they use. And it's a usable approach to thinking, not only for environmental purposes, but in economic sense as well, because it allows you to catch all the loose strings economically and tie them back into your system, which is always better for the system economically.
Yeah, well, Nikola,
from the side of knowledge, from the side of contacts as well, many useful contacts, including yourself and team. Also, people that were students as well as I have are people with whom I still have contact. A wonderful team. So it's many uses. Basically.
Perfect.
And I hope that we will have a collaboration in the future.
Yeah, I actually wanted to say, I mean, this is kind of a complementary, symbiotic acting of two different companies or two different actors in the whole system that could support each other. So not only that we could support you, but it would be pretentious to say, but you could support us as well in all the the narrative. And what gives me goosebumps is finally we managed here to talk with someone that thinks in circular systems. That was for me. That was aha moment from your talk, because it's really hard to explain to someone when you're talking about these meta things. I mean, people usually relate to this as meta thing, like systems thing. Okay, now it's too much of different. Yeah, it's different, but give me KPIs. But and in that sense, myself, when I was designing some of the products, also was you have to be engraved in this kind of thinking. You have to think from the very, oh, what happens with this product? How can I turn it back? How can I sell it on the other hand? How can I, reduce the impact? This can be, beneficial for this part of the life cycle, that part of the life cycle. Let's see, oh, now I know this and that friend that actually produces this and that. Maybe this will be useful for them. Let's try to sell and resell and buy, etc. So it's kind of a completely different logic of economics that we're building. And maybe for the last question, I will check what time do we have yet, is what would be your pledge for 2021? What will be the next thing, the next big thing in 2021 for Biosporin, for yourself, that you would like to commit to?
Well, as I said previously, this year has been full of a crisis, but let's emerge from this year trying to solve the crisis that was before this health crisis. So let's emerge in 2021 on the way to solve the pollution crisis and on the way to solve the environmental crisis as much as we can. So we plan to be aligned with that vision. We plan to push our product, to technically iron it out, to make it better and better, to innovate it, and to push into different industries and break into big industries as a sustainable packaging. For instance, the electronics industry is one of the biggest sources of pollution from microplastics, of which styrofoam is also a part. So that's one of our goals, to push into the tech industry as a sustainable packaging.
Nice. Yeah, we'll try to follow you on this pathway and support as much as possible. Being that it is 3:15 and we have to be very precise, I would hereby like to thank Nikola, and definitely this is maybe the first time we're putting this online and in this kind of conversation, but this is just the first step, and we will definitely foster some more either communication or facilitation or help up between us.
Looking forward to it.
Thank you very much, Nikola. It was amazing having you. And now I would like to inform all the audience to follow the rest of the conference and that we will having in hall number 1, and where we will talk about the opportunities in Balkan countries a green, digital, and health transition that is moderated by our Greek colleagues. So if you're streaming, try to click, or not try to click, but click on hall 1. If you're on YouTube, go and see what is other on our repertoire for Circular Economy Beacons Conference. Nikola, once again, thank you immensely, and see you soon. Bye-bye.